Hey folks, welcome to chapter 4. This is all about the entity relationship model and doing entity relationship modeling. So with chapter 4, we're going to introduce a lot more specific terms and add additional notation to the models that we looked at in chapters 2 and 3. So the book spends a little bit of time on the Chen model and then essentially says it's worthless. It's fine for conceptual diagramming, but anytime we actually want to start getting to more implementation level, we're going to get rid of it. So we're not going to spend a lot of time on Chen notation. You can check it out in the book. Again, it's not that it's not important, but what we want to focus on is the crow's foot notation and the UML notation, which are both much more suited towards the implementation oriented modeling, so I can actually take my model and implement it without having to go through a bunch of extra steps here. So some of our terms, again, we've talked about entities, right, being a table. The entity being a table means that a row in that table is sometimes referred to as the entity instance or the entity occurrence. Most of the time our entities are nouns. Right? That's typically how we go about designing a process. They don't necessarily have to be, but most of the time they end up being a noun. And then our entities will have attributes, right? So our entities are the tables here, right? So we have student is the entity. And then the attributes are the different columns here. So a student has an ID, right? A student has a name. A student probably has a phone number, right? We got all of these different attributes here belong as part of the entity. So every instance, right, or every occurrence, right, is the row here. So this is the occurrence. Now, typically when we do our models, and we want to start getting into nice detail here, we'll do it with, we'll start with the crow's foot model, because again, the Chen model is just not quite as useful here. So we'd say, hey, I have an ID, I have a name, and again, it's probably first name, last name, that sort of thing. We want to break those out so that the field only holds a single value here. We'll probably have a phone, an email, right? All sorts of that good stuff here. So some additional notation, it's a little harder to do with my pen here, that you'll get, what you'll see when we start getting to our tools, is that if something is required versus optional. Now, when we looked at doing our data modeling, we talked about if the field, it can be null or not. If it can be null, it's optional. I mean, it's not required. If it can't be null, it must have a value. So typically what you do is the fields here will show up in bold if they're required. And this is my poor man's bold here. So ID is required. Again, we probably require first and last name, that sort of thing. Maybe not everyone has a phone number. Right, and we know we're going to generate student email addresses for you. So maybe email is required here. So that's for optional versus required when it comes to attributes. The idea of a domain, an attribute domain, right? Still perfectly fine. So phone numbers here, we have, I don't know, 001 to 999 for area code, and then again 99, I don't know, 00. I'm pretty sure all zeros aren't actually valid, but I don't know that for sure. I don't really know a whole lot about phone numbers. Right? So if you wanted to break out area code and then the 7 digits, sure, we have some sort of domain that says, hey, this is the valid range for these. Domains are a little bit tricky to actually enforce at the database level. So typically we're going to note it here when we're doing our modeling, but that's the kind of thing that is going to usually be implemented at the application level. Right, and then when we come to identifiers, or specifically the primary key is mostly what we're going to show. We don't often show the candidate keys or any of those super keys or that other fun stuff. We might underline our attribute here because, hey, this one is the key in our table. And sometimes you might list these out. So the book goes through a little bit of this notation saying, hey, here's my student entity, and then in parentheses I'll give it a list here. So I'll have the ID as the key required here, and again that'd probably be in bold. Obviously the primary key is going to be required, and then I have their first name here in bold, and then maybe the phone number is not bolded, right? Because maybe phone number is optional. So we can kind of identify it in that sort of way here. And again, this works whether or not the primary key is a single field or a composite key. So if your primary key consists of two different values, we just underline them both. Right? They're both required, and that's perfectly fine. I'm sorry, they're both part of the key. Right? Your primary key can be made up of multiple fields as a composite key. There's nothing wrong with that. You just say that's what it is. For attributes, it spends a little bit of time talking about this idea of them being single-valued attributes or multi-valued attributes. And I guess at the conceptual level, multi-valued attributes are fine, but you just can't implement a multi-valued attribute. We know that kind of breaks our database rules. So what we do is we have to break those off into either separate attributes here, that we just list all these extra things here, or we could do a joining table. Right? So if we wanted to list, say, maybe the organizations that a student is part of, we would have another table that we relate to here, and we could relate to the orgs that they're a part of. So you're not going to list them all out here. It's just bad design to say, hey, I need 3 different fields because you might be a part of 3 different organizations. Right? We want to break those out into a separate table here. And then some students might not be a part of any organizations. So we can have different ways of storing those. So that, yeah, the implementation of multicolored values, or oh my goodness, I'm losing my words, multi-valued attributes here. So again, typically the one-to-many sort of thing. And then another fun thing you can do with your attributes is you can have derived attributes. So if you wanted, age is a great example here. I'm probably not going to store your age as an integer. I store that age as a number because then I have to change it every time you have a birthday. What I'm probably going to store is your date of birth. And if I have your date of birth, then I can compute your age based on, hey, what is today? Subtract your date of birth, and I can figure out your age. And then it goes through a couple examples here, but you'll call this a derived attribute here. So we could either compute it on demand, or we could store it. And there's trade-offs either way here. So you can, every time you have to compute it, it does take a little bit of CPU time, right? If you have to compute it, but the disadvantage is you have to go and update it every single time, right? So if you are going to store age, because you don't have to compute it every time you want to know, hey, show me all the people who are 20 to 24 here. You have to go and change it every time they have a birthday, and that takes up some additional work there. All right, why don't we pause here? We'll pick it back up in a little bit in another section.